Hello everyone. Today I will talk about cythonizing numpy code. There are two benefits for this. One is to hide your Python implementations. The other one is to get extra speedup. I was actually a little suspicious on the second point, but I will show you it is indeed possible. So I already have some code written, some very simple geometric operations. So you can see here, let me make it bigger. So I just want to do geometrical inversions. So we have some numpy array, say n by 3 coordinate matrix, and we have an inversion center, so we just want to invert the coordinates. Now here I also use the numba code for speedup. If you have numba code, it's very easy to get the extra speedup. All you need to do is just write some decorators, or you can write some code at the module level to decorate everything. Here this ngit means it's a shortcut for JIT Python equals false, which will give you the real speedup. Here cache equals true means you don't want to always compile on the fly. You only want to compile once and use the compiled file somewhere on disk. Okay, now let me also show you the Cython version, cinf.pyx. Yeah, so the Cython version is very similar. Here I give you two implementations and see what the difference is. So the first one is very straightforward. You can see what we do is first we get an empty matrix, and then we start to put in the set values entry by entry instead of using the numpy slices. Okay, later on I will show you this one is actually pretty slow, and then here is a faster implementation. So for this one, what we do is first we create some kind of Cython array object, and then assign a memory view to it, and then also we do the entry by entry set instead of the slicing set. There are some other details here, like we need to annotate the types. For example, the input is a numpy array in the original version. Here we will say it is a memory view, which is a 2D array, and you could write it like write it like this, which already means it's 2D array, but the extra stuff, the comma 1 here tells it it's a C continuous array, so it gives more information. For I don't know if that gives much speed up, but it tells it it's a continuous matrix with a C convention. Okay, and then you type the second argument, also type the returns. Also, there are some other stuff you can set here. They are called compiler directives. They provide some extra speed up because you basically tell it we don't check the index bounds and we don't allow the wrapping around index, which means you cannot set a negative index for it, which will make it more like C, so you get extra speed up. Okay, now let's use IPython to run them. So I also included here a README file. I will put this repo in the description. So there's an easy way to run everything just inside the IPython, so I don't need to write a main file. Okay, let me just copy this code and go back to IPython, just paste them. I mean, here it's very straightforward. What we do is we import this pyx import and then call this install command. What it does is it will allow you to compile the pyx files on the fly. and then we import the Python version and also the SciPy version, Cython version. Then we create a random matrix, and then we call the inversion with 1,000 rows, and then just time the 4 different implementations. So you can guess which one will be fast. I mean, the first one will be the baseline, and presumably the number will create some speed up. So this one, the second one, should be a little bit faster, and presumably these 2 Cython version will also be faster, but you will see what happens. Okay, there are some warnings. It doesn't really matter. Okay, now you can see the first one is the baseline, the original Python version, which is almost the same as the numba version. The first Cython version is much slower actually, and the last one is say more than 3 times faster. Let's do this again. So I suppose it will be surprising to you why this Python, the first Cython version is quite slow. It's way slower. I will show you later. Yeah, if I render again, you see the number version is a little more faster. But the Cython version is still consistently, the first Cython version is consistently much slower, and the second one is much faster. Yeah, I just want to see again what happens for the number version. Yeah, the number version is also consistently faster than the first one. I think the reason the first time it's kind of slow is because it is compiling on the fly, so it also took some time to compile. Okay, now let me just quit and then show you kind of why the first SciPy version is slow. Let me just go back to show you the first SciPy version. So it's actually not very different from the second one. You see, the only difference is here I used a numpy call. Here I used some other SciPy array. But I also did a memory view assignment. Actually, this is the key to get the speed up. Okay, let me show you what's going on. So Cython has a nice way to see what is being what Python code is being turned into C. So if you do this -a, which means annotate the code, it will generate a HTML file as an output, and then it will show you which part has been converted more into C. So here you can see in the HTML files, the one that's more yellow means there are more Python interactions. So if you click on them, it will expand into the real C code. And if there are many lines of C code, they will make it more yellow. So you can see here in my second implementation, there's only one line that's yellow, which is this array assignment. But all the other code is essentially just very close to C. But here you can see this assignment, which should be just C-like, they are still yellow. And the reason is that here this got is a Python object. As a result, you are indexing a Python object, so it's still a lot of Python stuff going on. It's still kind of Python indexing. So in order to get rid of that, we just need this line, which uses a SciPy memory view object. It's like the same thing. We turn our input into a memory view, and then this part will be a C object. Then this assignment becomes C assignment. Okay, let me just quickly show you that. So we can just copy this one to here, and then we can change this got to MV. Okay, let's try it again. So if everything works out, we will see invert 1 should be similar to invert 2. Yeah, you can see it's already much faster. Let's just run it again. Yeah, so that means whether you use numpy empty or use this Cython array, it doesn't really make much difference. Yeah, they are basically the same. Okay, I will upload this code to GitHub repo and put it in the video description. Okay, that's all I want to talk about today. Thanks for watching.